Hello, everyone, and welcome to today's webinar presentation, What to Consider When Moving IoT Data into Cloud Platforms, brought to you by HiveMQ. I'd like to introduce our presenter. Gaurav has led product marketing at HiveMQ since 2021, based in Ottawa, Canada. Gaurav is an engineer by education and a marketer by profession. He has worked in telecoms, networking, unified communications, software-defined storage, and software broker technologies. As a former solutions architect and product manager, Gaurav's work in marketing carries a blend of technological depth and the big picture. I'll now throw it over to Gaurav for our presentation.
Excellent. Thank you, Rich. Greatly appreciated. Hi, everyone. Welcome to this webinar on moving IoT data to the cloud. So as Rich mentioned, my name is Gaurav, and I lead product marketing at HiveMQ. I'm based out of Ottawa, Canada. I started my career in mid-2000s in the telecoms world, and for about 4 years now, I have been working in the software technology industry, and I'm really loving it. A quick introduction to HiveMQ for you. We are a global company founded about 10 years ago, headquartered in Germany. We help move data to and from connected devices in an efficient, fast, and reliable manner. We have approximately 150 customers now, and our customers are from a variety of industries, including media, automotive, manufacturing, and platform companies. I'm happy to be here and share with you some of what we understand as key factors to keep in mind when moving IoT data to the cloud. I think a good place to start is to know if this movement of IoT data to the cloud is really a trend. Now, the hyperscalers have a lot of services, right? And with hyperscalers, I mean AWS, Google Cloud, Microsoft Azure, Alibaba Cloud, and the likes. They have a lot of services which can help you meet your business needs. In fact, I'm sharing here from the latest report of the research firm IoT Analytics, which finds that almost 80% of all IoT specific services worldwide are available through the hyperscalers. So with that in mind, let's look at the topic at hand. The 5 criteria that you want to keep in mind when building your IoT data ingestion strategy for the cloud. And before we start, let me attempt some mind reading here. Not really mind reading, but I just want to make sure you are at the right place. And I want to make sure this is who you sound like. So tell me if this is what you sound like. Your IoT data is continuing to grow and you are considering or maybe already using the cloud for the following reasons. 1, it's very expensive to keep all your IoT data on premises. And second, there are amazing services available in the cloud that keep and perhaps help you analyze your data and help your business performance. That said, you want to keep control. You want to choose and use the right solution for your problem and not be held hostage by any provider. You know that however big a cloud provider is, they do face outages. You want to know what's wrong when there's an outage so you can deal with it on your terms. You are also responsible for architecting and building solutions that are reliable and efficient, and you demand the same from your cloud providers. I hope that made sense, and let's now dive in. So there are 5 criteria to keep in mind when evaluating your cloud provider for IoT workloads: flexibility, efficiency, avoiding getting locked in, deep observability, and the reliability of the solutions itself. Now, I'm not calling out security specifically here, but that doesn't mean that it's not important. We are basing our conversation today on the understanding that all major cloud providers have decent security controls. So let's start with flexibility. And the flexibility I'm talking about here is to be able to choose exactly what you need. Now, I don't need to tell you that delicately slicing sushi and cutting open a coconut requires totally different skills and different tools. The equivalent in our world of IoT is to route your data into a cloud that offers the best service for your use case, analytics, storage, or anything else that you want done. So think about how you will decouple the IoT infrastructure in your network from the cloud services. And if you can do that, then you can route your IoT data to a destination of your choice. It could be AWS for analytics, Google for long-term storage, and Azure for serverless functions, however you want it. You keep that control. And another very interesting way that we see businesses demand and implement flexibility is by extending their cloud services to their premises. So take a look here. This is an interesting approach because in case of a cloud outage or the cloud connection going down, the location can continue to work with the help of a broker, and that broker can keep all the data ready for when the cloud is back online. So you perhaps can get a sense of that here, that by having topic structures, you can streamline that data. And even if there's an outage, you have a way to link back up to the cloud and get online as soon as the connectivity is back or the cloud is back online. Let's now look at the efficiency aspect. And the concept I want you to keep in mind here is gathering on the edge and inferring in the cloud. Interestingly, Gartner points out that 3/4 of all the data that will be produced by the year 2025 will be happening on the edge. Now, it's obvious that not all of that data can or should make its way to the cloud. And that's why you need a way to regulate how much data must go to the cloud. You got to remember that the cloud has a bit of a Hotel California problem going. You probably remember that number from the Eagles, and the famous line that you can check out anytime you like, but you can never leave. And think about that when you think about sending data into the cloud. It's going to be expensive and it's going to be prohibitive to get it back. So you should really consider building a layer that can span the multiple clouds and a system that can help you stream only relevant information that you can then infer and analyze in the cloud. MQTT, for instance, which is the de facto standard, the de facto protocol for IoT, that gives you very granular and deep filters. And there are features like reporting by exception, which can help you conserve bandwidth and cloud resources. So keep that in mind, please. Let's now look at what I feel is among the more important considerations here: avoiding vendor lock-in. Now, this can really hurt your strategy, and that's why it's important to watch out for the signs, right? And here are the signs. So if your cloud provider is insisting that you use their proprietary clients or their reporting systems will work best with what they call certified clients, there is a problem. Another issue is non-compliance to IoT standards like MQTT. And they might have their own adaptations, but you don't have to compromise on what you deploy in your estate. So what you will see happening is no support for shared subscriptions. So you study the protocol, you say, okay, IoT is what I want to do, MQTT is how I want to do it, I want to implement quality of service, and then you realize that your cloud provider does not support QoS mapping, or if they do, they have their own workarounds which don't work, and suddenly your design begins to have to make some compromises there. But the estate that I mentioned, the estate that you want to keep your control over, so let's talk about that estate and how far should you draw this boundary line of your control. So what we see is that successful IoT businesses will retain the control of their architecture by deploying standards-based technologies. But unfortunately, no hyperscaler will fully support open standard protocols like MQTT. As I mentioned before, they'll have their own quirks and adaptations of MQTT, which means many of the features are not supported. So what we are suggesting here is that you need to find an appropriate interface with the cloud that gives you the control to be granular with your traffic to and from the cloud. Now, in case of Microsoft Azure, for example, that's the example I have here on the screen for you. The Event Hubs service, that takes a similar role as, say, Apache Kafka. Now, both Apache Kafka and Event Hubs, they are both distributed partitioned commit logs, which can buffer a message for you for a limited time. And then they can make them available through APIs for downstream applications like Azure ML and things like that. So this queue, in a way, becomes a central element of the architecture from which messages can be distributed to various backend applications. And the layer that you install between your IoT infrastructure and Event Hubs can give you that governance, that control that you need. And a couple of things which you'll see happen is you'll be able to query the individual endpoints, you'll be able to see active sessions, etc. That's something we'll talk more about in the next section here, which is the section on observability. Bear with me, I'm just having some trouble moving the slides here. There we go. So let's talk about observability now. And the mantra that that I want you to keep in mind is knowing what's wrong, or at least know where it is wrong. So we need to appreciate that IoT is quite unique. Imagine a connected car which has 1,000 or so sensors, and it's hooked up to cellular connectivity and then into the cloud. It goes inside a tunnel, and then suddenly all of this data becomes unavailable to your systems. So that's the kind of complexity we are dealing with here. The cellular network is good, the cloud is good, but then the car goes in a tunnel, and you have to now deal with a situation where there's a huge variety of sensors, there can be many vendors, but there's no standardized reporting or management system. And what's challenging when you look at a cloud provider, and they tend to give you what they will call edge to cloud service, is that almost all of your IoT architecture will turn into a black box. And it's very difficult then for you to figure out what went wrong and where. You don't know if it's the cellular portion which has gone down, did something happen inside the cloud there? And it means that you don't have good updates, you don't have good understanding of what was the root cause of our issue, and your struggles around observability are perhaps exacerbated by the fact that even your APM tools are of no help, because the whole cloud deployment turns into a bit of a black box. So what you should look for, right? These are the cautions I shared with you, but what you should look for in your cloud provider because of this is that they should give you detailed logs. They should give you proper traceability, ideally support for standards like OpenTelemetry, centralized logging of all the action happening in your IoT estate, detailed metrics, and the ability to also query and visibility into individual endpoints and active sessions. You know, if there's a rogue endpoint, if something is going wrong, you want to be able to go in there and deal with it. So the last, but by no means the least thing here is the reliability aspect. We know that the cloud does become unavailable and inaccessible from time to time. I was reading some reports which said every major cloud provider has gone down by an average of 2 last year. So that said, you need to be able to, because of that reason, plan for some outage scenarios. The first one is the outage of the platform itself. The second is very high number of connection requests after the cloud service comes back online. Remember, if a cloud goes down, thousands of customers are impacted. And when it's coming back online, now everybody's trying to connect all at the same time. So it's another scenario of some degree of denial of service that you might experience there. Or the third one is the network connecting you to the cloud itself is impacted. So what you need to be able to achieve with your provider, despite the outage, is that one, any crucial business processes should still continue on your location, which, by the way, going back to that flexibility I was talking to you about early on, it's possible with the architecture I showed you there. Second, the ability to connect a large number of devices after a cloud or a network disruption. So this is again the layer that you can plant between your IoT infrastructure and your cloud. That's the one which can retain the session information, and that will also mean that no spurious connections can creep in, and you have a very predictable, governed way to connect the clients back to the cloud. And also the ability to troubleshoot and spot where the issue is. This links back to the point I made about observability. All right, so we've covered a lot here. Those were the five considerations I wanted to talk to you about. And if I read your mind right early on, and I'm sure by now you want a bit of a summary view of everything we've covered here. So what your cloud IoT data ingestion strategy should include, this is strategy, this is not a product, this is not a cloud platform. I'm saying your strategy should include support for a broad variety of edge devices and no proprietary clients, a governed and bi-directional mechanism to route IoT data between endpoints and the purpose relevant clouds. Third, streamlining data so you can make sure that you're only sending necessary data to the cloud. Having very clear red lines for cloud vendors, which if crossed, you should be aware that you will get logged in. Have an in-depth understanding of the logs, metrics, and other controls available to you for managing your architecture, and have a plan to deal with cloud outages and interruptions. So I hope that made sense. And as you chart out your next steps, we would love for you to consider HiveMQ's MQTT broker platform. And as you can see here, HiveMQ can help you, create that governed connectivity layer between the various components of your architecture. And all of this will happen without any proprietary clients. You get to choose your clouds. There are filters available to efficiently move your data to the cloud. There's full traceability and 1,500 and counting metrics for deep observability, and clustering of brokers for high uptime, and it can scale to millions and millions of endpoints. One of the largest deployment we have is 200 plus million endpoints for a client. And there's a variety of extensions available to you to adapt the platform exactly to your business needs. So speaking of extensions, what we do is that our MQTT broker platform comes with an enterprise SDK, which has an open API, and that allows you to modify it. And it's written in Java, so it's easy for people to understand and play with this. You can pretty much bring your business logic on top of the MQTT broker. So you are distributing your data, you are making sure you're not relying on any one platform or a cloud provider. And that is something that you can do based on the capabilities of the enterprise SDK that we provide. Now, that's one option, but then we also have pre-built extensions available for Apache Kafka, also to extend our enterprise security services, and also for bridging between different MQTT clusters. So we are a platform which does not lock you into any one deployment platform. We are, as you can see, enabling a multi-cloud strategy for you, which will allow our broker to be deployed pretty much anywhere, and we also come in a fully managed cloud avatar. One thing which deserves a shout out here, a special shout out perhaps, is the HiveMQ enterprise extension for Kafka. So this is the one I mentioned when we were talking about interfacing with Microsoft Azure Event Hubs. So what we are doing here is the Kafka extension is a native implementation of the Apache Kafka protocol, and it is guaranteeing end-to-end persistence of messages. It's bidirectional. And as you can imagine here, what we are doing is we are, in a way, giving you queuing capabilities on a very popular queuing platform, queuing and streaming platform of Apache Kafka. And we can do MQTT to Kafka and Kafka to MQTT mapping. So that's the bidirectional aspect I mentioned to you. So what you saw today is based on our experience with customers from various industries. We actively contribute to MQTT specification committee, and we are already involved in new age standards like Sparkplug. The platform, the broker itself, is available in different editions for different needs, and we also offer a cloud version. Our community edition is available at no cost for non-production use cases, and it's a great place to try out some of the amazing features that we offer. We are consistently publishing content and demos that can help you accelerate your IoT journey, so I invite you to check them out on our website. And that said, I believe this is a good time for us to answer some questions. Let me check the panel here. Right, let's tackle this one, which is a common question around compliance to MQTT standards and what that means for a business. So what does it mean if a cloud is not fully MQTT compliant? That's the essence of the question here. So MQTT is a de facto protocol for the Internet of Things. Today, almost all major IoT platforms and practically all suppliers of edge computing hardware would support MQTT. It's lightweight, it's an open standard, it's truly becoming the most preferred protocol for connecting things to the internet. Now, how does this help you? Let's look at a couple of features around efficiency, one of the considerations I talked to you before. So let me actually pull up something on our website here that will help us relate with this concept a little better. And this concept is the idea of shared subscription. So I'm gonna bring into the screen here some information on shared subscriptions, and perhaps this visual will speak for itself. So MQTT version 5. So there's two versions, version 3, version 5, and HiveMQ fully supports both. And by the way, interestingly, no hyperscaler platform supports MQTT 5. as of today, and there's no sort of expressed confirmation on when they will start doing it. Irrespective, so MQTT 5 standardizes this concept of a shared subscription. Now, what it does is it allows multiple MQTT client instances to share the same subscription on the broker. So what's happening here, as you can see, is there are clients which are reading from the same topic, and that message in a way is getting distributed. So once it's ending up here on this client, and the second time it's ending up here. So you're able to load balance, and this could happen between, say, two different cloud deployments. So this helps you load balance in a cloud cluster. It's useful when you use your MQTT client to store and forward MQTT messages into, say, an ESB or any kind of a database. So that's something which shared subscription does for you. Another interesting element in my mind is the topic aliases. So these are just a reminder. I'm picking up a couple of examples which should give us a sense of, okay, why compliance is important. If somebody complies, what does it mean? What does it do for you? So these are all controls and features that you can then use to implement exactly to your business case. So topic aliases. Now, topics for anybody in the enterprise architecture space would know that it's essential to a broker architecture. That's what helps you create a sort of a access mechanism, if you will, which explains, okay, how do I access a certain data set or a certain data point? So a topic can be pretty long, and the one I've highlighted here for you, you can see it's a certain kind of data in a certain continent, in a certain region, and so on and so forth. Now, this can get, in case of a deployment which has got millions of connected devices and perhaps transmitting billions of messages, this string itself can take up a lot of resources, not just the bandwidth, but also compute resources for your infrastructure. So what MQTT 5 does is it allows you to replace it, or rather I should say have an alias which is simply an integer. So in this case, you can keep that mapping around, say, the topic name 1 corresponds to what you can see here in the visual. So with that, you are able to more effectively manage your infrastructure. So that's on the efficiency aspect. Now, from the overall management perspective, what MQTT 5 also does is it offers you reason codes. So reason codes are handy because imagine, right, you have got, in the case of IoT, you've got cars on the street. There are machines which are running on a factory floor, or you are remote monitoring very valuable assets, right? So you need to be able to track what's going on with them. If a connection is dropping, you want to be able to know why, or perhaps if that happens often, or you don't even realize if it's happening often or not, but that data is what you want to send into the cloud. So the machine learning systems and other services can help you see what's going on. They can do a degree of assessment, predictive analysis, perhaps. So you want a good sense of reason codes, right? Why did this happen? Why did a connection close? So MQTT 5, for example, has got those features built in. And just a reminder, because cloud providers don't support MQTT 5, you don't get any of that graceful understanding of what's happening with your IoT connections. Now, from a management perspective, again, there is a feature which I find really interesting, and what it's called is last will and testament. I believe it's also in MQTT 3. It's not just a 5 feature, it's also available in 3. So that is like a fail-safe. So what happens when you lose a connection, right? So just as the connection is going out, it's the last thing that the client wanted you to know. You could be anything on the other side. It could be a dashboard. What is it that reading system has to know about the client which just went offline? So the last will and testament, it communicates that information, which could simply be, hey, I'm disconnected, right? And that's information you flash on a dashboard. Or if you see that happening and 5 similar other last will and testament messages coming your way, you might want to trigger an alternate workflow. But these are things you can only do if you have got those controls. And with MQTT, full MQTT compliance, you get these. And these are unfortunately not available in hyperscalers. So you end up having to build workarounds and and trying to meet your business needs for these important breakpoints in your workflows, that's not going to be a good use of your time and your team's time. So that's something I felt I should mention with respect to compliance. So okay, moving on. Okay, speaking of cloud, I think there is good interest in understanding what that proposition looks like from a HiveMQ perspective. So let me open the HiveMQ cloud page, and people want to know what it is and the kind of capabilities it has. So I think the easiest way for me to just show you the web page for HiveMQ Cloud. So you're welcome to go in here, and maybe I didn't mention it before, but you're welcome to sign up and connect up to 100 devices for free. So this is available to you now to use if you like. So that's HiveMQ Cloud. So what it is really is it's a managed cloud-based broker, and this managed cloud-based broker takes care of all the scaling that is necessary. It's full-featured. So instead of deploying and managing a HiveMQ broker on your infrastructure, you simply use our API to connect with the cloud-based broker, and then you can keep scaling from there, and you get the benefits of clustering and everything else. Another interesting aspect here is the fact that it is connected with the Confluent Cloud. So I know Kafka is a topic of significant interest in the dev community. So there is an extension available, as I mentioned, for Kafka, and we are integrating with Confluent Cloud also. So you can stream data between your HiveMQ, I should say your MQTT portion of your deployment and the Kafka side of your deployment. So if it's on Confluent, we integrate fully well with them. We've done some articles and videos demos with them in the past. And like I said, you can also do this if you're doing Kafka in-house or through any other means. You can integrate using our Apache Kafka extension as well. And yeah, like I said, there's significant interest in Kafka. Let me also actually show you the other set of information we have on the web page, on our website rather, around Kafka through Confluent. So please, you're welcome to take a look and get a better understanding of what this looks like. Okay. Yeah. So there's interest in Kafka here, I see, and staying on that topic, let's dive deeper a bit and talk about the extension for Kafka. So, okay, so I think the questions are around overall extensions and the Kafka extension in particular. So extensions are there to help you use the broker and align it with your business logic and your business needs. So one of our more popular extensions is the Apache Kafka extension. And for HiveMQ, that's at the core of this really. Extensibility is one of our key principles. We want to make sure our platform is able to adapt to what our customers need. So we do this for security, for bridging use cases, etc. And for the Kafka extension, remember, we are not a messaging queuing system. That's not what HiveMQ does. HiveMQ is an MQTT broker, and then we extend our amazing broker capabilities into a queuing system or an ESB, and that gives you the full ability to support MQTT 3 or MQTT 5. This means that all the good features I mentioned before, like retained messaging, retained messages, QoS support, etc., that's all stuff which we can then support onwards into Kafka. An interesting, I think, mention here will be of what we are doing with respect to Azure Event Hubs. And this is an article written by my colleague Matthias, who's a senior consultant in our professional services team. So he's explaining here in this beautifully written blog post, and we also did a demo and a walkthrough of this integration. So as you can see here, Azure Event Hubs is quite similar to the Kafka architecture. So what that does is that if you have HiveMQ running with Kafka extension, you can map into that namespace and keep moving your messages into different event hub queues and then onwards into other backend services. So as you can see here, right, I mean, Kafka can come in and become that message queue, which can help you link up to, in this case, Azure Event Hubs, and obviously we can work with you to find a similar architectural integration points for other clouds. So so remember, you are it's easy to miss. So I must point out, you are speaking to the Azure cloud here without using their IoT service. You are speaking to Azure Event Hubs. You're not speaking to an IoT service here. So you have been able to retain control with everything you wanted to do on your IoT estate, and then you're plugging into Azure Event Hubs. And that's what gives you the full control you need on the QoS mapping. You're able to create your priorities. You're able to use this platform as a tool in your toolkit, and you're not locked in, you're not dependent entirely on how one provider might serve you. So that's the questions I see on here, and I believe that's all the questions we are getting, because I'm not seeing anything else coming in here. So I'm gonna just go back to my presentation and see, Rich, is there anything else we need to cover here, or any questions you might be seeing which I'm not?
No, I think we had one or two more questions in the chat, but I think you covered them.
Okay.
So I think if there's nothing else from you, we can go ahead and wrap up. Does that sound good?
Absolutely, it
Great.
for sure does. And yeah, I invite you to people to check out the website for resources I mentioned before. There's evaluation versions. There's also a great guide to get started with MQTT, so that's a good place for people to start. So yeah, so I invite all the listeners here today to check out our resources.
Great. And you also included your contact information for LinkedIn and email if people want to get in touch with you directly.
100%. So it's on the screen now. So people are welcome to connect with me. I'll be happy to get in touch. Yeah.
Okay. With that, DZone would like to thank Gaurav for a great presentation. We'd also like to thank HiveMQ for providing our audience with an outstanding webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.